back to Gatemate. In our previous session, we learned about generative AI, large language models, prompt engineering, business applications, and APIs. Now, in today's session, we are going to understand technical foundation behind modern AI system. Our topic is LLM architecture, technical understanding of large language models. Today, we will learn how models like ChatGPT actually process languages internally using transformers and attention mechanism. Let's quickly look at the today's agenda. First, we will discuss what large language models are and how they are involved over time. Then we will discuss transformer architecture, then after attention mechanism, then self-attention, then multi-head attention, and finally we will understand pre-training, fine-tuning, and future scopes of LLMs. This session will help you understand the core technical concept behind modern AI systems. Now, let us understand the key mechanism behind large language models. Model LLMs are mainly built using transformer architecture. Earlier, AI systems used recurrent models, but transformer made processing much faster and more efficient. One major concept is the attention mechanism. Attention helps the model decide which words are most important while understanding a sentence. For example, in the sentence, the cat sat on the mat because it is tired. The model understands that it refers to the cat. Another important concept is self-attention. Here, every word compares itself with the every other words in the sentence to understand relationships and context. Then we will also have multi-head attention, where multiple attention mechanism works in parallel and focus on different patterns. Finally, model go through pre-training and fine-tuning. Pre-training teaches general languages understanding, while fine-tuning adapts the model for a specific task. Now, let's understand what LLMs actually are. LLMs are neural network trained on massive text data sets. They are designed to predict the next token or next word in a sentence. For example, if the input is artificial intelligence is, the model predict the next word, probably word based on pattern it's learned during the training. This next token prediction process is the core training objective of LLMs. As the models begin larger and trained on the more data, they develop advanced capabilities such as summarization, translation, coding, reasoning, and question answering. Today's these models are used in search engines, chatbots, context generation, AI assistants, and customer supports. Now, let us understand how NLP architecture evolved over time. In 1980s, systems were rule-based. Developer manually wrote grammars and language rules. This system were limited because they could not learn from the data. In the 1990s, recurrent neural network or RNN were introduced. RNN could process sequence of text and remember previous information. Later, LSTMS improved memory handling for long sequences, but these models still have limitations: slow training, difficult handling long context. Then in 2017, transformers were introduced. Transformer completely changed the NLP because they allowed parallel processing, better text, long text understanding, and faster training. That is why Transformer becomes the foundation of modern LLMs. Now, let us discuss transformer architecture in detail. Transformer mainly contains encoder, decoder, attention layer, feedback networks, and potential encoding. The encoders converts input into the conceptual representation. Decoder generates output tokens one by one. Attention layers help the model focus on relevant information. Feed forward network process and refines the information further. Now, one challenges with transformer is that they process all words in parallel. So how does the model understand words order? This is solved using the positioning encoding, which gives position information to every tokens. Together, these components allow transformer to understand language efficiently. Now let us understand the attention mechanism, which is the heart of transformer. Attention allows the model to focus more on the important words than less on the irrelevant words. For example, in a long sentences, not every word contributes equally. The model assigns higher importance to the relevant tokens. Attention also helps capture long distance relationships. This means the models can connect words that are far apart in the sentences. This improves translation, context understanding, and text generation. In a simple word, attention works somewhat like human focus. Human also focus more on important information while ignoring noises. Now let's go deeper into attention, self-attention. Self-attention helps each token interact with every token in a sequence. This process uses three components: query, key, and value. The query represents what each token is searching for. The key represents the identify or characteristics of tokens, and the value contains the actual information. The model compares queries and keys to calculate similarity scores. Based on these scores, attention weights are generated. Then the values are combined to create the conceptual outputs. This process helps the model understand meaning based on the surrounding context. Now let us understand multi-thread attention. Instead of using only one attention system, transformer use multiple attention heads working in parallel. Each head focuses on different types of relationship. For example, one head may focus on grammar, another on sentence meanings, another on position relationship. After processing all the outputs and combined together, this creates richer and more powerful representations. The advantages of multi-head attentions is better accuracy, better context understanding, reduce blind spots. This is the one reason why transformers are so powerful. Finally, let us understand pre-training and fine-tuning. During pre-training, models learn generally language knowledges from massive data sets. This builds foundation understanding. After pre-training, the model is fine-tuned for a specific task or industries such as healthcare, legal system, enterprise AI. Fine-tuning improves accuracy for spliced use cases. Now, looking at the future, AI systems are moving towards multimodal AI agents, more efficient architecture. Future AI will combine text, images, audio, video. We will also see AI agents capable of planning tasks, calling tools, and executing workflows automatically. So, today we learn LLM architecture, transformer, attention mechanism, self-attention, multi-head attention, pre-training and fine-tuning. This concept from the technical backbones of modern AI system. Thank you everyone, and I will see you in the next session.